So a monomial is a number, variable, or product of a number and one or more variables. And they're non-negative integer exponents. So we're talking about anything that's like a number would be like 12. Or a variable where you could have 12x because that's a product, which means multiplication. I could have x squared because my squared is a non-negative, it's positive. And a constant is a monomial that is a real number. So a constant would be like 12. So for our following examples, we need to determine whether each expression is a monomial. Well, the first one, does it fit my definition? Is it a number, variable, or product of something? So it's a number, so A is yes. B, I have f plus 24. Well, addition is not product, and I just don't have a number, and I don't have just a variable. I have an addition expression. So this is actually not a monomial because it's not a number, variable, or product. H squared really means h times h, which is a product. So this is a monomial. J is just a variable, so that's a monomial as well. And then the next one, though I have multiplication up top, I also have this division statement. And division is not a monomial, so this is no. When I have a product of powers, when I have two powers that have the same base, I'm always going to add my exponents. So if I have the base of A plus A, I'm going to add their exponents. So let's look at our first example. I have 3n, or 6n to the third power, times 2n to the seventh power. So I'm going to multiply my constants, which are 6 and 2, so I get 12. And then my bases are the same of n. So based on my definition, I need to add my exponents. So I'm going to have n to the 10th power because I added my exponents. Go ahead and look at the next example. So the first thing I'm going to do is I have 3 times 1, so I just have 3. I'm going to add my exponents, so p to the first power, because any variable by itself always has an understood coefficient of 1. So 1 plus 3 is 4. So I have p to the fourth, and then t to the third and t to the fourth become t to the seventh power. So I added my exponents. Go ahead and pause the video and try the next two examples on your own. So for my first one, I'm going to get 21 y to the 9th because I added my exponents. And then for my next one, I'm going to get 24 r to the 6th, x to the 7th, and t to the 4th power. So when I have a power times a power, I'm going to multiply my exponents. For example, if I have 6 to the 3rd times that to the 8th power, this really equals 6 to the 24th power. So all I did was I multiplied my two exponents of 3 times 8 to get me 6 to the 24th. So when I have a power of a product, I can actually distribute my exponent. So let's take a look at this first example. If I had negative 2x times y to the third times all of that to the 5th power, I'm just going to distribute my exponent. So I'm going to have negative 2 to the 5th times this x to the 5th, because x times 1 is x to the 1st, and then times 5, and then I get y to the 15th, because 3 times 5 is 15. And then negative 2 to the 5th power equals negative 32. So I have negative 32, x to the 5th, y to the 15th. Go ahead and try this example on your own. So I'm going to have 4 squared, and then x to the 4th, y to the 6th. 4 squared becomes 16, x to the 4th, y to the 6th.